welcome back. In the previous lessons, you learned how to work with units and how to make simple conversions. Today, we move to two new physical quantities, area and volume. These quantities help us describe surfaces and space. You will see that the ideas are not new. They are built on what you already know. Let's start with area. Area tells us how much surface an object covers. When we talk about area, we always think about flat shapes. For example, the surface of a desk or the floor of a room. Area is measured in square units. This means length multiplied by length. Let us look at a simple example. Imagine a rectangle. Its length is 4 meters, and its width is 3 meters. To find the area, we multiply the two values. 4 multiplied by 3 gives 12. The unit becomes square meters. So the area of the rectangle is 12 square meters. The number tells us how large the surface is. Before solving a complex problem, let us review the most important area formulas. These formulas are tools you will use again and again. We start with the triangle. The area of a triangle is equal to the base multiplied by the height, divided by 2. Area equals base times height over 2. Next is the square. All sides are equal. The area of a square is the side multiplied by itself. Area equals side squared. Now the rectangle. A rectangle has a length and a width. The area is found by multiplying length by width. Area equals length times width. Let us move to the parallelogram. A parallelogram looks like a slanted rectangle. Its area is the base multiplied by the height. Area equals base times height. Next is the trapezoid. A trapezoid has two parallel bases. To find its area, we add the two bases, multiply by the height, and divide by 2. Your area equals the sum of the bases times the height over 2. Finally, the circle. A circle has no sides or corners. Its area depends on the radius. Area equals pi multiplied by the radius squared. These formulas help us break complex shapes into simple ones. If you know these formulas well, solving area problems becomes much easier. So far, you learned how to calculate area for regular shapes and how to work with area units. Let us look at a real situation. We will solve it step by step. Find the area of the shaded region shown in the figure below. The dimensions are indicated on the diagram. Express the area in SI units. Let us find the area of the shaded region step by step, exactly as shown in the images. All the dimensions are in centimeters, so the areas we calculate first will be in square centimeters. At the end, we will convert the result to SI units, which means square meters. First, look at the left part. It is a rectangle. Its height is 30 centimeters and its width is 15, so the area of the rectangle is length times width, 30 times 15. That gives 450 square centimeters. Now look at the right part. It is a triangle. For the triangle, we use area equals base times height divided by 2. Here, the height is 30 centimeters and the base is 50 centimeters. So we calculate 30 times 50 divided by 2. That gives 750 square centimeters. Now look at the small square in the upper left corner. This square has a side length of 10 centimeters. Because all sides are equal, it is a square. To find its area, we multiply the side by itself. 10 centimeters multiplied by 10 centimeters gives 100 square centimeters. This square is not part of the shaded region. It is removed from the large shape. That is why we must subtract its area from the total area we calculated earlier. At this point, we add the two parts to get the area of the whole big shape before removing the cutout. So 450 plus 750 gives 1200 square centimeters. Now notice the small square cut out in the top left corner. Its side length is 10 centimeters. So its area is 10 squared, which is 100 square centimeters. The shaded area is the big area minus the cutout. So we calculate 1200 minus 100. That gives 1100 square centimeters. Now we convert to SI units. 1 square meter equals 10,000 square centimeters. So we divide 1100 by 10,000. The result is 0.11 square meters. Final answer. The shaded area is 0.11 mètres carrés. Now let us move to volume. Volume tells us how much space an object occupies. Volume is used for solid objects. Think about a box, a bottle, or a room. Volume is measured in cubic units. This means length multiplied by length multiplied by length. Now that you know what volume is and how it describes space in 3 dimensions, it is time to apply this knowledge to a real problem. We will work step by step, using unit conversions and volume formulas, exactly as we did for area. Find the volume of unused marble when a cube with side length L0 equals 0.5 decimeter is made from a block with the following dimensions. Length L equal 120 centimeter, width L equal 400 millimeter, height H equal 1 decimeter. First, we need all dimensions in the same unit. We will work in decimeters, because the cube side is given in decimeters. Let us convert each dimension. The length is 120 centimeters. Since 10 centimeters make 1 decimeter, 120 centimeters is equal to 12 decimeters. The width is 400 millimeters. Since 100 millimeters make 1 decimeter, 400 millimeters is equal to 4 decimeters. The height is already given as 1 decimeter, so no conversion is needed. Now we calculate the volume of the original marble block. The volume of a rectangular block is length times width times height. So we multiply 12 decimeters by 4 decimeters by 1 decimeter. 12 times 4 times 1 gives 48. The volume of the marble block is 48 cubic decimeters. Next, we calculate the volume of the cube that is made from the block. The volume of a cube is the side multiplied by itself 3 times. The side of the cube is 0.5 decimeters. So we calculate 0.5 times 0.5 times 0.5. This gives 0.125 cubic decimeters. Now we find the unused marble volume. We subtract the volume of the cube from the volume of the original block. 48 minus 0.125 gives 47.875. Final answer. The volume of unused marble is 47.875 cubic decimeters. This lesson ends here. You have learned how to work with volume and how to solve practical problems step by step. These ideas will help you understand many situations in physics. In the next lesson, we will begin a new chapter. Mechanical phenomena. Our first lesson in this chapter will be about body, motion, reference point, reference system. If you found this lesson helpful, like the video and subscribe to the channel Geo Stuff. This helps you keep up with the next lessons and supports the channel. See you in the next lesson.